So properties of rational exponents. We may say laws of rational exponents. One of the laws of rational exponents is this one. If I gave you a to some power m times a to some power n, when you multiply both of those, you add the exponents. It's going to equal to a to the sum of m and n. Whatever that sum is, it's going to be the new power that a is going to be raised to. So for example, if I gave you 3 to the 5th plus 3 to the 1/2, if you add those, it's going to be 3 to the 5 plus 1/2. Or if you combine 5 1/2, this is going to be 11 over 2, ultimately. Because it's got to be 5.5, so 11 over 2 is 5.5. So anyway, you can rewrite it that way, or you can write it as 5.5. It's easy to see as 11 over 2, because the number index is 2 and my exponent is 11. So you can truthfully call that the square root of 3 to the 11th power. So that's what 3 to the 5th plus 3 to the 1/2 is, basically the square root of 3 to the 11th power. So that's one of the properties. Another property is if you divide those, for example, a to the m divided by a to the n. You actually divide those, you may already know, you subtract the exponents. So it's a to the m subtract n. So that's how it works. I guess as an example, if I gave you 3 to the 6th divided by 3 to the 3rd, you wind up having 3 to the 6th subtract 3, which is 3 to the 3rd. And that would be the answer for it. Third property deals with, suppose I gave you a to the negative m. That's the same thing as having 1 divided by a to the positive m. So if a negative exponent, it means move it across the division bar. Another property is a to the m raised to the n. This property is a power to a power, and if you have a power to a power, you multiply the exponents. So it's going to equal to the product of m and n. Number 5 would be the property that says if I have the product of a and b raised to the n power, that means that you basically raise each of the numbers to that power. So a, b to the n power is a to the n power and b to the n power. And then the sixth property would be if I gave you a divided by b to the nth power is equivalent to a to the nth divided by b to the nth. So those are all of the properties or laws that deal with exponents. You're gonna need this lesson. In this lesson, you're gonna focus on having rational exponents. So you can see more and more of the exponents being 1/2 or some other mixed number and so forth. So when we pause the video, be sure to get all those down as a note. And now let's go into it. Okay, so directions are to evaluate each expression. So basically evaluate means find the value of each expression. And if I gave you x to the 4th times x to the 7th, what we now know is it's x to the 4 plus 7, giving you the exponent of x to the 11th power. If I gave you this, I would first rewrite it as, well, for one, you can say it's y to the 4 plus negative 7. And so we know 4 plus a negative 7 should be y to the negative 3. And what we also know is y to the negative 3 means 1 over y to the positive 3. So I found the answer is 1 over y cubed. In this case, we have a power and another power, and both have a base of c, so we can subtract the exponents. C to the 9 subtract 5 gives you c to the positive 4. That would be the final answer there. In this case, we have a power raised to a power, and we should multiply the exponents. So this is b to the 4 times 5, which is b to the 20th power. So that would be the answer for that one. Look at a couple more like those though. So give you 3 to the x to the 3rd Well, this is going to be 3 to the third times x to the third, which is 27 x to the third. Let's find an answer there. We gave you this problem, which is x over 2 raised to the 5th power. You raise the top part to the 5th power and everything on the bottom to the 5th power. And you may know that 2 to the 5th is really 2 cubed times 2 squared. So if you don't know what they are, you can figure out 2 cubed is, well, that's 8. 2 squared is 4. So 2 to the 5th is really 8 times 4, which is 32. So I know 2 to the 5th power has to be 32. So this would be the answer there. X to the 5th over 32. And the last one has y over 7 raised to the negative 1. If you have some raised to the negative 1, it means raise this one to the negative 1 and raise that one to the negative 1. So if that was the case, y will go to the bottom and 7 will come up. So basically, you ever see something raised to the negative 1, basically gives you the right to flip everything in the fraction. So if that's the case, the 7 comes on top of the fraction, the y comes on the bottom of the fraction, and the 1 becomes positive. So y over 7 to the negative 1, the same thing 7 y to the positive 1. So anyway, that's it with this, the basics of the exponents. Let's do some more though. We have a new set of problems, new set of directions. Take a moment, write them down, see if you actually figure out what the values are on your own first, and then we'll talk about them. So take a moment, pause the video, write down all the ones you see, so you can find the value of those on your own. If you can't, don't worry, I will give you an explanation of it. So pause it now. Okay, so if you try to pause it, you should have found that this part is raised to the 1st power, because there's no number there, so I don't have to change it at all. So it's going to be 2 times a to the 3rd times b squared times, it's all been multiplied, times whatever all this stuff is cubed. So the cube really means write it 3 times, or if we follow our rule, we can just raise each one to the 3rd power. So it means 3 cubed, a cubed, and b to the 12th. Because power to the power, you multiply and get 12. So now we can look to see if we have anything we can actually simplify more. For example, 2 times 3 cubed. Well, that's going to be 2 times 27. So that's 54. They have an a cubed times an a cubed. So that's a to the 6th. They have a b squared times a b to the 12th, which is b to the 14th. And the reason why I know they're all times, because no sign between there, I know all these been multiplied. So because they've been multiplied, I can multiply them in any order and regroup the a's, regroup the numbers, regroup the b's, and so forth. So I found the answer is this one. In the second example, I have a negative 4 on the exponent there. I have a positive 4 exponent here. If you remember from the last lower note I gave, if you have a negative exponent on the outside of this parentheses, and you have a fraction there, you really should just flip everything inside parentheses. Make the exponent positive. So now that's going to be y over x to the positive 4 times, we'll go raise each of those to the 4th. It's going to be y to the 8th times x to the 4th all over z to the 4th. And this is also y to the 4th all over x to the 4th times y to the 8th times x to the 4th all over z to the 4th. So if I multiply those, I wind up having y to the 4th times y to the 8th is y to the 12th times x to the 4th all over x to the 4th times z to the 4th. You may recognize these cancel because they're the same variable, same bases, and same exponents, so they reduce to be 1. So you only have enough y to the 12th on top, all over z to the 4th on the bottom. You can't reduce that because they're unlike bases. This base is y, and that. You can't reduce it because they're unlike bases. This base is y, and that base is z. And that's just what it is. So our final answer is y to the 12th divided by z to the 4th. All right, so last set of examples. So in this example, I have a negative exponent. I got negative exponents all throughout there. So I'd rather work with this negative exponent first, get that out of the way. So that's the case, I'm going to flip all this stuff, making it now x squared, y cubed, z to the negative 4 on top, and x, y to the negative 2, z to the negative 3 on bottom. And that negative 3 outside becomes a positive 3. Next thing I understand is, if I'm going to cube this, I need to cube everything in there. So every exponent needs to be raised to the 3rd power. So that makes this now x to the 6th, and then y to the 9th, and z to the 12th, divided by x to the 3rd, y to the negative 6th, and z to the negative 9. And basically, when you see negative exponents, it means you can move them across the division bar. If it was on the bottom of the division bar, you can move it up. If it was on top of the division bar, you can move it down. So this is now x to the 6th, y to the 9th, z to the 12th, and then y to the positive 6, and z to the positive 9, all been multiplied in the numerator. And the denominator is just x to the 3rd left. So again, this negative exponent should be moved to the top. And then I can look at what can be multiplied together. For example, I have x cubed there and x to the 6th there. If you subtract those exponents, it should be x cubed left over. And this reduces to be just plain old x to the 3rd on top. And that has a 1 on the bottom. So notice a 1 down there. Y to the 9th times y to the 6th is y to the 15th. And z to the 12th and z to the 9th is z to the 21st. There's nothing left on the bottom but a 1, so I don't really have to write that anymore. So I can just call my final answer x cubed times y to the 15th times z to the 21st. So that's the final answer for it. In this last one, I would really think about this, having the 3 halves as my index being 2, and my exponent being 3. So that means I have the square root of 4 x to the 6th y cubed, no, y to the 8th cubed. I really don't like cubing it before I square root it, so I'm going to rewrite this as the square root of 4 x to the 6th y to the 8th, and take everything that's being cubed and cube it later. So I can square root each of these terms. Each of these terms are perfect squares. So because these are even exponents, they're perfect squares. And because that's a 4, it's a perfect square. So this is now square root of 4 times the square root of x to the 6th times the square root of y to the 8th raised to the 3rd. Again, you don't have to write the 2. It's understood there when you're writing square roots. So this is now 2 times x to the 3rd. Next, that's right. The square root of x to the 6th means x to the 6th divided by 2, which is x to the 3rd. So yeah, you just divide the exponent by 2. And the square root of y to the 4th should be, y to the 8th should be y to the 4th. This is all being cubed. So now after I square rooted, I can cube each number. 2 cubed. And then x cubed cubed. That's x to the 9th power. And then y to the 4th cubed. That's y to the 12th power. You should know 2 cubed is 8. So it's 8 x to the 9th, y to the 12th. And that's the final answer. Guys, that's all I have. With that being said, good luck on tonight's homework.